The universe does not hold a mirror of glass and silver. Its reflection is older, deeper, and stranger. A mirror that does not show the present, but the end. In the silence after creation, the cosmos trembled with its own birth. Out of the blinding fire of the Big Bang, there lingered a faint afterglow, the cosmic microwave background, a hushed light that still covers the sky, invisible to the naked eye, yet speaking of origins. But hidden within that light lies something more unsettling, the whisper of destiny. The first glow does not simply describe the past. It bends forward, hinting at the fate that awaits. Galaxies drift across space-time like apparitions on a polished surface. Stars flare, only to collapse into shadows. Time stretches like a corridor, one end glowing with the fire of creation, the other darkened by silence. Einstein revealed that space-time curves back upon itself, bending beginnings toward endings, making the universe its own reflection. Thermodynamics adds its decree. Entropy must rise, every flame must cool, every birth carries death within it. And in the trembling of quantum fields, the vacuum itself shivers, as if waiting for collapse. If this mirror exists, then nothing is truly random. The final silence of the cosmos was already written into its first cry. The end is not a stranger, but a reflection carried within the birth of time itself. And so the question emerges, what does it mean to live inside a universe where the end has already been seen, not ahead of us, but behind, written into the first light of the cosmos? The first mirrors were not made of glass. There were pools of water, obsidian stones, the still surface of lakes reflecting stars above. Ancient humans, gazing upward at the night sky, felt the same sensation, that the heavens themselves were a mirror. The cycles of the moon, the predictable wandering of planets, the return of eclipses, all were rhythms, repeating reflections of something eternal. To them, endings and beginnings were never far apart, one folded into the other. In the hymns of Hindu cosmology, the universe breathes in cycles, creation followed by destruction, then rebirth again. In the Rig Veda, time is described not as a line, but as an ocean of endless creation and dissolution, where the end already waits inside the beginning. The Stoics of ancient Greece spoke of ekpyrosis, the great conflagration where the cosmos burns in fire only to be reborn exactly as before. Mayan myth traced the rise and fall of multiple worlds, each echoing the others like repeating reflections. Humanity's first intuitions of the cosmos were not of progress, but of cycles, endings mirrored in beginnings. But myth gave way to mathematics. The 19th century brought the first true glimpse of the mirror hidden in nature, entropy. In the work of Clausius, Boltzmann, and Kelvin, the second law of thermodynamics emerged like a whisper from the equations. Every system, they realized, tended toward disorder. Heat spread, energy diluted, no flame could burn forever. Each moment carried within it the signature of its eventual stillness. This was the first scientific reflection of the mirror, the recognition that the end is written into the present, inevitable and irreversible. It was a shocking revelation. To the Victorian imagination, progress seemed endless. Steam engines, locomotives, electricity, all appeared to signal infinite growth. Yet physics declared otherwise. However vast the cosmos might be, its destiny was not eternal vitality, but exhaustion. Entropy decreed a future of silence, the heat death of the universe. The first edge of the mirror had been glimpsed, not in myth, but in calculation. Then came a revolution that deepened the reflection. In 1915, Albert Einstein presented general relativity. Space and time, once thought to be rigid, absolute, and eternal, were revealed as pliable, dynamic, alive with curvature. Gravity was no longer a force pulling at a distance, but the bending of space-time itself. Planets orbited not because of invisible strings, but because mass shaped the very stage on which motion played. Within the equations of relativity lay strange solutions, universes that curved inward, universes that stretched outward, universes that pulsed in cycles. Suddenly, the cosmos itself was not infinite and static, but fragile, dynamic, and temporary. The mirror grew vast. Time and space were revealed not as endless corridors, but as canvases with edges, where beginnings and endings could be inscribed only. A year later, as if fate conspired, Karl Schwarzschild, a soldier in the trenches of the First World War, found the first exact solution to Einstein's equations. It described a sphere so dense that not even light could escape its gravity, though no one yet called it so. This was the mathematics of a black hole, a cosmic mirror within a mirror, an object where time itself ended, and yet whose boundary reflected information in ways not yet understood. At the heart of relativity, beginnings and endings were already entangled. For decades, however, such conclusions were dismissed as abstractions. Even Einstein himself resisted the idea of collapsing. Stars are expanding universes. The cosmos was assumed to be eternal, unchanging, infinite. But the mirror could not be ignored. In the 1920s, Georges Lemaitre, a Belgian priest and physicist, suggested something radical. If the universe is expanding, as Einstein's equations allowed, then it must once have been smaller, denser, hotter. Perhaps, he proposed, it began in a single event, a primeval atom exploding outward. The American astronomer Edwin Hubble, observing galaxies from Mount Wilson Observatory in California, confirmed that galaxies were receding from us. The farther they were, the faster they fled. The universe was expanding. The mirror now revealed something breathtaking. If one looks forward, expansion implies an ending. But if one looks backward, it reveals a beginning. This was the birth of the Big Bang Theory, a cosmos with an origin, a moment when time and space themselves burst into being. For the first time, scientists could not only speculate on endings, but trace them directly from the beginning. The final piece of the mirror emerged in 1965, almost by accident. Two engineers at Bell Labs, Arno Penzias and Robert Wilson, were testing a radio antenna when they encountered an inexplicable hiss, a faint background noise that would not go away. At first they thought it was interference, even pigeon droppings, inside the antenna, but it was not terrestrial. It came from every direction, uniform across the sky. It was the faint afterglow of the Big Bang itself, stretched by 13.8 billion years of expansion. The cosmic microwave background, CMB, was discovered, a relic light older than galaxies, older than stars, a fossil glow carrying the memory of the universe when it was only 380,000 years old. But hidden in this light was more than memory. The CMB contained tiny fluctuations, ripples, the fingerprints of structure itself. Within these ripples lay the blueprint of galaxies yet to be born, clusters yet to gather, and voids yet to spread. And in those same patterns, the trajectory of the cosmos could be read forward, like lines in a reflection that shows not only the face, but its aging. It was as though the universe had left behind a message, the same radiation that revealed its birth also whispered its fate. By studying this ancient light, scientists could measure the density of matter, the curvature of space, the strength of dark energy. They could forecast whether the cosmos would collapse back into itself, freeze in silence, or tear apart. The mirror was now tangible. The beginning did not merely hint at the end, it contained it. Entropy was no longer a local curiosity of steam engines and chemistry. It was cosmic, the stars burning across the sky, magnificent in their brilliance, were all temporary. Hydrogen would be exhausted, galaxies would dim, black holes would evaporate. The arrow of time, tilted by entropy, leaned toward stillness. The universe's beginning had encoded its own trajectory. The end was visible, faintly, in the very first light. For humanity, this realization was a philosophical rupture. If the end is inscribed in the beginning, then the present is not free but bound by inevitability. Stars live and die, galaxies form and dissolve, but all are walking toward an ending already written. The myths of eternal cycles, of time as a repeating circle, were replaced with the haunting possibility of linear destiny. A universe not endless, but finite. Not eternal, but mirrored between birth and silence. Thus, by the mid-20th century, the mirror had been fully revealed. In the equations of entropy, in the curvature of relativity, in the expansion measured by Hubble, and in the afterglow caught accidentally by Penzias and Wilson, science uncovered a haunting truth. The end of the universe is not separate from its birth. It is reflected in it. The cosmos had become a mirror that shows the end first. The revelation came not as a whisper, but as a rupture. Physics, once imagined as a set of steady rules, suddenly revealed a paradox. The universe had betrayed the illusion of permanence. Its earliest light did not only describe its origin, it contained the scaffolding of its fate. This was no ordinary discovery. It was a confrontation with inevitability. The paradox of the mirror was this: the universe at its birth carried within it signatures of its death. The tiny fluctuations of the cosmic microwave background, imprinted just after the Big Bang, were not random noise. They were the primordial blueprint. They dictated where galaxies would form, how clusters would emerge, and how expansion would proceed. The very geometry of space-time was written there. To study the past was to study the future, as though the cosmos itself were a mirror angled toward its own end. But what kind of end did the mirror reveal? The first and most chilling possibility was heat death. Entropy, the universal law of increasing disorder, declared that the cosmos was not on a path toward fire, but toward silence. Stars burn out, matter spreads thin, energy becomes evenly distributed, useless, unable to do work. In such a state, no structures survive, no thought remains, no process endures. The mirror showed not drama, but exhaustion, a universe in equilibrium, frozen in perfect stillness. The end, paradoxically, would not be an event, but the absence of events, the death of time itself. Yet even this bleak destiny was soon unsettled. In 1998, astronomers studying distant type Ia supernova discovered something astonishing. These exploding stars, used as cosmic mile markers, revealed that the universe's expansion was not slowing under gravity's pull, but accelerating. Something unseen was driving galaxies apart faster and faster. This was the birth of the concept now called dark energy. The shock was immense. For decades, cosmologists had debated whether the universe would expand forever into a cold void or collapse back upon itself in a fiery big crunch. Now a stranger future emerged, eternal acceleration. If dark energy continued its relentless work, then not only would galaxies drift away, but eventually their light would vanish beyond cosmic horizons. Civilizations, no matter how advanced, would be locked inside shrinking islands of visibility. The mirror now showed not merely stillness, but isolation. The universe would end not in one grand finale, but in countless little prisons of darkness. But darker possibilities lurked. Some models of dark energy suggested that its influence might grow stronger over time. If so, galaxies would not only drift apart, they would be torn apart. Clusters would dissolve, stars would separate, planets would be ripped from orbits, atoms would unravel. This nightmare became known as the Big Rip. The mirror reflected not stillness, but disintegration, the annihilation of structure itself, down to the fabric of space-slip at the same time. Quantum physics whispered an even more terrifying possibility, that the universe might not be stable at all. The discovery of the Higgs boson in 2012 brought with it a chilling calculation. According to some models, the Higgs field, which gives mass to particles, may not be in its lowest energy state. It could be metastable, like a ball perched precariously in a shallow valley. If a quantum fluctuation or cosmic event ever nudged it, the field could collapse into a lower state. This would release a bubble of new physics, expanding at nearly the speed of light, rewriting reality itself. No warning, no resistance. The mirror here reflected an end, sudden and absolute, vacuum decay. Black holes, too, revealed unsettling reflections, long thought of as eternal prisons. They were transformed by Stephen Hawking's insight in 1974. Quantum effects at their horizons meant they radiate faintly, losing mass until they eventually evaporate. Over unimaginable timescales, even the titans at galactic centers would fade into nothing. But Hawking's work raised another paradox, the information problem. If black holes erase matter, do they erase information itself? Quantum mechanics forbids such loss, yet relativity seemed to demand it. The contradiction between the two great pillars of physics cracked open a deeper truth. The laws of the universe may themselves be incomplete, and if black holes act as mirrors, reflecting information across their horizons, could the universe itself be such a structure? A cosmic horizon containing information about its end on its very surface. The suggestion hinted that space-time might not be what it seems, that beginnings and endings were bound in a single surface of reality, a mirror of unimaginable scale. The shocking conclusion was inescapable. Physics had revealed that the present cannot be understood without the end. Every major theory, from thermodynamics to relativity to quantum field theory, pointed toward a symmetry. Beginnings and endings are intertwined. Entropy guarantees eventual silence. Expansion accelerates into isolation or rupture. Quantum mechanics allows instant annihilation, and black holes demonstrate that time and space themselves may reflect their own limits. The mirror no longer belonged to myth. It was no longer an allegory or a poetic metaphor. It had become a measurable fact of science. The universe, in its first light, in its deepest equations, carried the script of its own demise. For humanity, this realization was both terrifying and profound. To look at the night sky was to see more than beauty. Every galaxy was not only a beacon of light, but a fragment of destiny, already moving toward an end it could not escape. Every star was a reflection, its future death folded into its present brilliance. The cosmos was not an open book of infinite possibility, but a mirror where endings are inscribed at the moment of birth. It was a revelation that shattered the illusion of permanence, not only for the universe, but for existence itself. To live, to breathe, to think, all our processes carried forward by entropy, carried toward equilibrium, carried inevitably toward stillness. Life, fleeting and fragile, is a rebellion against the mirror, a temporary flicker before silence, and yet in this shock lay a strange kind of beauty. The mirror did not diminish the universe, it deepened it, for what could be more mysterious than a cosmos that shows its end in its beginning? What could be more haunting than a reality where every moment carries its destiny within it? The scientific shock was not only in the equations, it was in the realization that to exist is to be, reflected to carry the imprint of an ending already written, even as the story unfolds. The shock had passed, but not the unease. The universe was not only expanding, not only aging, it was revealing patterns that tied its first whispers to its last breath. The scientific community turned from astonishment to scrutiny, from revelation to relentless investigation. If the mirror truly showed the end within the beginning, then perhaps the path of destiny could be traced more clearly, measured more precisely, mapped in the very fabric of light. The work began with the cosmic microwave background, the faint relic glow discovered in 1965 by Arno Penzias and Robert Wilson. At first, this radiation appeared uniform, a near-perfect blanket of microwave light bathing the cosmos. But satellites such as COBE in the early 1990s, and later WMAP and Planck, uncovered something astonishing: tiny fluctuations in temperature, just 1 part in 100,000. These were not random imperfections, they were the fingerprints of quantum ripples stretched by inflation, sound waves frozen into the infant plasma of the universe. The peaks and troughs of those ancient oscillations became the scaffolding of galaxies. More profoundly, these same fluctuations dictated the overall fate of expansion. The universe's geometry, density, and ultimate trajectory were encoded in those faint patterns. To map the CMB was to gaze not only backward in time, but forward. The investigation deepened with baryon acoustic oscillations. These fossil sound waves, imprinted on the distribution of galaxies, acted as cosmic rulers. Surveys such as SDSS, Sloan Digital Sky Survey, and DESI traced these ripples across billions of light years. What they revealed was not chaos, but resonance. Galaxies were not scattered randomly. They were strung like pearls along the echoes of the first sound waves. Each echo provided a fixed scale against which cosmic expansion could be measured. By observing how that scale stretched with time, astronomers could constrain the acceleration of the universe and glimpse within ancient sound the rhythm of its end. The deaths of stars provided another key. Type Ia supernova, uniform in brightness, served as cosmic markers. By charting their light across vast distances, scientists reconstructed the tempo of expansion. It was through these stellar funerals that dark energy was first revealed, and each new observation refined its nature, narrowing the possibilities for the universe's destiny. Would expansion continue steadily, or accelerate without bound? Would the mirror reflect stillness or disintegration? The answers lay hidden in the supernova's fading glow. Then came a revolution: gravitational waves. In 2015, LIGO detected ripples in space-time from colliding black holes, confirming Einstein's century-old prediction. These waves opened a new sense: the ability to listen to the universe itself. And like echoes in a vast chamber, gravitational waves hinted at deep symmetry. They carried information not only about cataclysmic events, but potentially about the structure of space-time itself. If detected across cosmological scales, they could reveal whether the universe's expansion carries a rhythm tied to its origin, and perhaps to its end. Even black holes, once thought to be dead ends, became tools. Hawking radiation transformed them from eternal prisons into evaporating objects. If true, their final whispers of radiation might provide clues about the universe's own ultimate evaporation. Black holes, in their deaths, could mirror the death of the cosmos itself. Their paradoxes of lost information, of horizons acting as mirrors of reality, forced physicists to reconsider whether the universe was itself a kind of black hole, with its beginning and ending bound on a horizon we cannot yet see. Simulations added another layer. Supercomputers, fed with the laws of physics and the seeds of primordial fluctuations, recreated universes in silico. Projects like the Illustrious and Millennium simulations revealed webs of galaxies forming along invisible scaffolds of dark matter. They demonstrated how ancient sound waves sculpted the distribution of matter, and how expansion dictated the pace of structure's growth. In these digital mirrors, scientists could fast-forward time, watching universes evolve toward their endings. Some froze into heat death, some collapsed, some tore apart. The possibilities were endless, yet all of them were rooted in the same primordial fingerprints observed in the CMB. But the investigation did not stop at stars and galaxies. It reached deeper into chemistry itself. Astronomers studied the most ancient stars in the Milky Way halo, ultra-metal poor stars, relics from the earliest generations. Their chemical makeup carried clues about the first supernova, the ashes of the universe's infancy. Some of these explosions may have left behind black holes, seeds that grew into the giants at galactic centers. If so, then even today's quasars, brilliant beacons powered by supermassive black holes, are reflections of those first collapses. The mirror, again, showed continuity, from first death to final fate. The cosmic microwave background also provided constraints on an even stranger idea: primordial black holes. If black holes formed in the first instance after the Big Bang, their signatures might be written into the CMB or into gravitational lensing of distant light. If detected, they could explain dark matter, and they would suggest that the universe carried within its very birth the seeds of both structure and destruction. To find them would be to find ashes of endings older than stars themselves. Then came gravitational wave detections of unexpected black hole mergers. Some were far more massive than anticipated, suggesting that not all black holes came from ordinary stars. Could these be primordial relics, survivors from the earliest epochs? If so, then the universe was already populated with scars of collapse before galaxies even formed. The mirror was not smooth, but cracked with ancient shadows. Anomalies further deepened the mystery. The Bullet Cluster, a collision of galaxy clusters, revealed a strange separation, visible matter lagging behind, while invisible mass surged ahead. Through gravitational lensing, scientists mapped this unseen matter, concluding it must exist, dark matter. But what if dark matter itself were made of primordial black holes? If true, the cosmos was not only shaped by invisible scaffolds, but haunted by ancient collapses from its birth. The mirror, again, showed endings nested inside beginnings at every turn. Deeper investigation revealed a haunting symmetry. The universe's future was not open-ended chaos, but constrained by patterns laid down in its first instance. Fluctuations in the CMB dictated the growth of structure. Fossil sound waves determined expansion. Supernova mapped acceleration. Gravitational waves echoed the hidden rhythm. Black holes mirrored transformation. The early universe was not only a starting point, but a script. And yet, anomalies persisted. Some CMB regions, the so-called cold spot, alignments dubbed the axis of evil, resisted explanation. Were they mere statistical flukes, or whispers of something deeper, perhaps tied to the universe's fate? Some simulations suggested such anomalies could indicate unusual physics at the largest scales, perhaps evidence of a multiverse or of geometry not captured by standard cosmology. If true, then the mirror was more than reflection. It was distortion, revealing shapes not yet understood. The investigation grew philosophical. If the first moments dictated the last, then what role did chance play? Was the universe's destiny inevitable from the instant of the Big Bang, or did quantum uncertainty allow forks, divergences, alternate futures? Physicists debated whether entropy's arrow was absolute, or if cycles, collapses, and bounces might renew creation endlessly. Could the mirror show not one end, but infinite reflections? By the 21st century, humanity had assembled an arsenal of instruments. Satellites mapped radiation with exquisite precision. Surveys traced galaxies across billions of light-years. Interferometers listened to space-time itself. Underground detectors searched for dark matter. Each tool chipped away at the veil, sharpening the image of the mirror. And what emerged was not clarity, but layers of mystery. For every pattern discovered, new questions arose. The deeper the investigation went, the more unsettling the symmetry appeared. It was no longer possible to view the cosmos as an unfolding story written moment by moment. Instead, it seemed to be a reflection, a structure in which beginnings and endings were already bound. The first light of the universe did not merely illuminate the past. It illuminated the script of the future, and within that realization lay both wonder and dread. Wonder that humanity could glimpse such profound connections through fragile instruments on a small planet. Dread that the mirror might already hold the ending, immutable, waiting. Science pressed forward, searching for cracks in the reflection, for signs that the story was not predetermined, that the end was not already etched in the beginning. Yet, with every new discovery, the haunting symmetry returned. The cosmos seemed less like an open book and more like a mirror, one that reflects the end first and only then reveals the present. The deeper science peered into the mirror, the less it resembled a simple reflection. What once appeared as a faint outline of destiny grew darker, stranger, and more fragile. Every new discovery added not certainty, but tension, as though the cosmos itself resisted being fully understood. The mirror no longer showed only symmetry. It revealed distortions, fractures, and terrifying possibilities. The end was not one picture, but many, and each possibility carried its own unease. The greatest fracture came with the enigma of dark energy. In 1998, two teams measuring distant supernova stumbled on something unexpected. The universe's expansion was not slowing, but accelerating. This revelation rewrote destiny in a single stroke. The cosmic mirror, once thought to point toward eventual collapse, now showed endings even more haunting. Instead of a cyclical rhythm or a final crunch, the universe might race outward forever. Galaxies would drift apart, stars would fade in isolation, and the night sky would grow empty. The end would not be violent fire, but infinite silence, a big freeze. But darker still was the possibility of the big rip. If dark energy's strength grows over time, the acceleration will not merely scatter galaxies, but tear them apart. Stars would be ripped from their orbits, planets from their suns, atoms from their nuclei, until space-time itself disintegrates. The mirror reflected a future where not even the fabric of existence survives. For the first time, humanity confronted the possibility that the universe might end not by exhaustion, but by dismemberment. Yet the mirror was not clear. Dark energy remained a name for ignorance, a placeholder for something unseen. Was it a property of space itself, a cosmological constant as Einstein once proposed? Or was it a dynamic field, evolving over time, capable of changing the destiny of everything? The reflection was unstable. One adjustment in data, one shift in theory, and the ending changed. Then came a new terror, the possibility of false vacuum decay. Quantum field theory suggests that the vacuum we inhabit, the energy state of space itself, may not be truly stable. If a lower energy state exists, then at any moment a bubble of true vacuum could appear, expanding at the speed of light, rewriting the laws of physics in an instant. Particles, forces, atoms, all would be obliterated, reconfigured under new rules. The end would be sudden, unheralded, unstoppable. Unlike the slow fade of entropy, this ending carried no warning. It was not heat death, nor rip, nor freeze, but annihilation, the extinguishing of our universe into something unrecognizable. In the mirror, beginnings and endings blurred. Perhaps our own cosmos was born of such a transition, and will one day perish in another. Even the cosmic microwave background carried distortions that deepened the mystery, while Planck's maps of the sky revealed astonishing precision. They also uncovered anomalies. The cold spot, larger and colder than chance predicts. Alignments of multipoles, nicknamed the axis of evil. Asymmetries across hemispheres. Were these statistical flukes? Or were they hints of hidden structure, imprints of physics beyond the known? Some theorists suggested they might signal interaction with other universes, collisions across cosmic boundaries. If true, then the mirror did not show a single ending, but infinite reflections. Our cosmos might be one pane in an endless hall of mirrors, each with its own destiny. The arrow of entropy added further unease. Entropy insists that disorder must always grow, that energy becomes less useful, that systems decay. Yet within this march toward silence, life and complexity arose. Galaxies formed, stars ignited, biology flourished. Was this order merely a temporary eddy in the tide of entropy, or did it hint at hidden laws, counterbalances not yet understood? If entropy reigns absolute, the mirror shows inevitability. Every birth contains death. But if order can persist, if complexity itself is a fundamental principle, then perhaps the end is not as final as it seems. Another fracture in the mirror emerged from the horizon problem. The universe expands so rapidly that distant regions recede beyond visibility. Every moment, galaxies slip past the cosmic horizon, vanishing forever from possibility of contact. The mirror of the end is not remote. It is happening now, with each horizon crossed. The future is being written not in billions of years, but in real time. The present already carries absence, a shrinking circle of what can ever be seen. Humanity stands at the center of a cosmos steadily losing itself. Even pulsars and gravitational waves began to complicate the reflection. Pulsars, once models of precision, sometimes glitched, abruptly altering their spin. Gravitational waves, once thought to come only from violent collisions, hinted at a deeper background hum, possibly from countless supermassive black hole binaries, or even from processes in the earliest universe. If confirmed, this hum would be the lowest note in the cosmic symphony, a reminder that the universe has always carried within it echoes of endings not yet arrived. The deepening of the mystery was not only scientific but philosophical. If the end is inscribed in the beginning, then is free will an illusion? Are human choices, civilizations, even histories, mere ripples on a river whose destination is already fixed? Or is the mirror deceptive, showing not inevitability but possibility? A spectrum of endings, with destiny chosen moment by moment. The escalation was not merely academic. Every new observation sharpened the paradox. Dark energy accelerated expansion. Vacuum instability haunted quantum fields. Entropy declared silence inevitable. Yet anomalies suggested hidden symmetries, perhaps cycles or rebirths. The mirror no longer showed a single reflection, but a gallery of endings, each more haunting than the last dot. And in this gallery, one realization became inescapable. Humanity was not outside the mirror, but inside it. Every heartbeat, every breath, every thought unfolded within a cosmos already carrying its end in its light. To look upward at the stars was not to see freedom, but reflection, the faint glimmer of a fate written long ago. The mystery had deepened beyond comfort. Science had hoped for clarity, for a stable picture of the future. Instead, it uncovered distortion, multiplicity, and fragility. The mirror that shows the end first was no longer a metaphor, but a condition of existence. The question was no longer whether the universe has an ending, but which one. And in that uncertainty lay the most haunting truth. The end may already be visible, yet forever beyond our power to change. The mirror of the cosmos does not yield a single reflection. Instead, it fractures into many, each theory a shard of possibility, each speculation an attempt to glimpse what lies beyond the veil. Scientists, armed with equations and telescopes, propose models not as certainties, but as maps of destiny drawn upon the unknown. These theories are not mere abstractions. They are visions of how time itself may end, written into the same mathematics that once revealed its beginning. The most familiar reflection is the vision of heat death, or the big freeze. Entropy is the tyrant of thermodynamics, and in its reign, the universe drifts toward equilibrium. Stars burn their fuel, galaxies exhaust their gas, black holes swallow what remains. In the far future, only cold embers and evaporating black holes will exist. No work will be possible, no energy gradients to exploit, no life to persist. This is not an ending of fire, but of silence, a universe stretched thin, uniform, and eternal in its stillness. The mirror here reflects inevitability, a slow dimming of the lights until even memory itself is swallowed by darkness. But another shard reveals the big rip, a fate stranger and more violent. If dark energy is not constant but grows with time, then its grip will eventually overcome every bond. First, galaxies are pulled apart. Then stars are wrenched from their orbits. Planets, molecules, even atoms succumb. Finally, space-time itself tears, as if the very fabric of reality splits into threads. This is the mirror as fracture, showing a universe destroyed not by exhaustion but by dismemberment, an unmaking written into the acceleration we observe today. Other reflections, however, reveal cycles. The Big Crunch, once considered likely before dark energy's discovery, imagines expansion halting and reversing. Galaxies converge, stars collide, temperatures rise, until all collapses into a final singularity. But within that singularity may lie a big bounce, a new expansion following collapse, a rhythm of universes born and reborn. Some cosmologists, such as those exploring loop quantum gravity, see in this possibility a way to reconcile beginnings and endings. The mirror here is not final but recursive, a circle in which every end is also another birth. Yet the mirror also whispers of stranger symmetries. Some models of time itself suggest that our universe may be only one branch of reality, its twin, running backward. In such primordial symmetries, the arrow of entropy points in opposite directions on either side of the Big Bang. Our universe marches toward heat death. Its reflection evolves in reverse, from silence to fire. The two together form a whole, a cosmic palindrome where beginning and end are one and the same dot. From the realm of black holes emerges another speculation, the holographic principle. This idea, born from the paradoxes of event horizons, proposes that the universe is not as it seems. Reality, with its depth and volume, may be a projection of information stored on a boundary. Just as a two-dimensional hologram encodes a three-dimensional image, the cosmos itself may be a hologram. In this reflection, the end is not destruction but re-encoding. What appears to vanish, stars, galaxies, memory, may in truth be inscribed on the cosmic boundary, written into the fabric of information itself. If so, the mirror is not metaphorical but literal, every moment reflected on the edge of reality. Then there is the possibility of the multiverse. In this reflection, our cosmos is but one among countless others, each with its own physics, its own beginning, its own end. Inflationary theory, when extended, suggests that expansion never truly stops. Instead, bubbles of universes form endlessly, each detached from the others, each a reflection in an infinite hall of mirrors. In this vision, the end of our universe is not final. It is merely one note in an eternal chorus of births and deaths. The mirror multiplies endlessly, revealing not destiny but infinity. The most unsettling reflection comes from false vacuum decay. In quantum field theory, the Higgs field determines the mass of particles, the stability of matter, the rules of physics. But calculations suggest that the vacuum state we inhabit may be only metastable. If so, the mirror shows fragility. At any moment, a bubble of lower energy vacuum could appear, expanding at light speed. Inside it, physics would be rewritten. Electrons might not exist. Chemistry might be impossible. Space-time itself could unravel. To live in such a universe is to walk across a frozen lake, knowing the ice may crack without warning. Here the mirror reflects not gradual endings, but sudden annihilation. The instant collapse of everything into something unrecognizable. Speculation does not end at destruction. Some theories imagine that endings themselves may seed new beginnings. Roger Penrose's conformal cyclic cosmology suggests that when the universe reaches its end, when black holes evaporate, when particles lose their distinctions, it becomes indistinguishable from the beginning of a new cosmos. The ashes of the end ignite a new dawn. In this reflection, time is infinite, a chain of eons linked by the silence between. The mirror here shows not doom, but renewal, creation, and collapse woven into an eternal tapestry. Other thinkers wander further into philosophy. If the universe has a pulse, as some models of oscillatory expansion suggest, then reality is more akin to music than machinery. Each cycle, each expansion, is a movement in a symphony, each end a cadence resolving into a new beginning. The mirror here reflects not inevitability but art, a cosmos whose destiny is not mechanical but aesthetic, whose laws are written as harmonies rather than equations. Still others see the mirror as infinite recursion, Nietzsche's eternal recurrence, the idea that all events repeat eternally, resonates strangely with cosmological models where the universe cycles endlessly. If every detail is destined to recur, then the end is never the end, but the prelude to the same song played again. For some, this is despair, a fate without escape. For others, it is liberation, meaning found in eternal return, in the affirmation of existence without end. In the gallery of mirrors, every theory reflects a different fate. Heat death shows silence. The Big Rip shows dismemberment. The Big Bounce shows rebirth. The holographic principle shows information preserved. The multiverse shows infinity. False vacuum decay shows fragility. Conformal cycles show renewal. Eternal recurrence shows repetition. Each theory is both science and poetry, mathematics and metaphor. None is proven, yet all are possible within the fabric of physics as we know it. What unites them is the recognition that endings are not accidents. They are written into the same laws that govern beginnings, the expansion of space, the behavior of entropy, the instability of quantum fields, all whisper of what must come. The mirror does not deceive. It illuminates the tension between fragility and eternity, between silence and renewal. And so the theories gather, not as answers but as reflections. Humanity stands before the mirror, gazing at its many shards, knowing that the reflection may be true, may be partial, may be distorted. Yet within those reflections lies the most haunting truth. The universe does not wait for an ending to be written. It carries its ending already, folded into its beginning, visible in the faintest glow of its birth. The mirror shows the end first, but in showing so many endings, it forces a deeper question: which reflection belongs to us? Theories without evidence are mirrors without glass. They reflect possibilities but remain intangible. To transform speculation into knowledge, science builds instruments, telescopes that drink starlight, detectors that listen for ripples. In space-time, colliders that recreate the furnace of creation. These tools are humanity's attempts to polish the cosmic mirror, to reveal whether the faint patterns in the beginning truly forecast the end. The search begins with telescopes, humanity's oldest windows into the universe. But the new generation is not content with visible light. The James Webb Space Telescope, JWST, peers into the infrared, gazing at galaxies so distant their light has been stretched by the expansion of space. It does not merely see their shapes, it traces their ages, their formation, their fate. Each faint galaxy Webb records in the first billion years after the Big Bang is not just a relic of the past, but a clue to the universe's trajectory. Are galaxies forming too quickly? Are structures too massive, too soon? These answers refine the mirror, showing whether the equations of expansion truly point toward eternal growth or sudden collapse. On Earth, preparations for even grander instruments unfold. The Vera C. Rubin Observatory, perched in the Chilean Andes, will map the night sky with unprecedented depth and frequency. It will chart billions of galaxies, tracing the subtle fingerprints of dark energy in their distribution. Each shift in clustering, each faint oscillation in cosmic structure carries information about the fate of the cosmos. By observing the rhythm of the universe's expansion across billions of years, Rubin may confirm whether the end is a freeze, a rip, or something stranger. Above, Europe's Euclid mission, launched in 2023, adds another layer of clarity. Its task, to measure cosmic geometry itself, mapping dark matter and dark energy across vast distances. Euclid does not seek to look at stars, but at scaffolding. By charting how light bends around invisible structures, it reconstructs the invisible architecture of spacetime. In these distortions may lie confirmation of whether dark energy is constant or variable, and with it, the key to whether the universe accelerates toward stillness or destruction. But telescopes are only one side of the mirror. Beneath mountains and ice sheets, scientists construct experiments not to look outward, but to measure the trembling of the cosmos itself. Cosmic Microwave Background (CMB) missions like Light Bayard and CMBS aim to detect the faint polarization patterns in relic radiation from the Big Bang. These patterns may carry traces of primordial gravitational waves, ripples from the first instance of inflation. By studying them, scientists can test whether the seeds of the universe's birth already inscribed its death. If inflation began with certain symmetries, then its end may be predetermined. The mirror of the CMB is not metaphorical, it is literal. Light from the first moments, carrying within it the whispers of destiny. Even more profound is the rise of gravitational wave astronomy. Since LIGO's first detection in 2015, humanity has learned to listen to spacetime itself. Each chirp of merging black holes or neutron stars is not only an event in isolation, but a test of Einstein's equations across extremes. In the coming decades, LISA, the Laser Interferometer Space Antenna, will orbit the Sun, listening for gravitational waves at longer wavelengths, the murmurs of supermassive black holes, the possible hum of the universe itself. If a background of low-frequency waves is found, it may be the universe's baseline, a rhythm that carries across eons. Within that rhythm could lie the story of expansion, and with it, the mirror of the end. On another front, pulsar timing arrays stretch across continents. Networks like Uneonograv, EPTA, and IPTA use the precision of pulsars, cosmic lighthouses flashing with atomic accuracy, to detect gravitational waves spanning decades. Already, Uneonograv has reported hints of a stochastic background, possibly from the dance of supermassive black holes in the early universe. If confirmed, these signals reveal more than astrophysics. They show how structure itself evolves, how galaxies merge, and how the fabric of spacetime trembles on the way to its fate. Pulsars, once thought curiosities, may become metronomes of destiny. The frontier extends into the smallest scales as well. Particle physics intersects with cosmology at the edges of understanding. At CERN's Large Hadron Collider, LHC, collisions probe the Higgs field, the very field that may determine whether our vacuum is stable or met. If the Higgs rests in a false vacuum, then the mirror shows fragility. The universe could collapse into a more stable state without warning. Experiments that refine the Higgs mass, its couplings, its stability, are not just particle physics. They are prophecies of cosmic survival. Future colliders, such as the proposed Future Circular Collider FCC, aim to push this further, mapping quantum fields with precision that could confirm or refute vacuum decay scenarios. If the Higgs is precarious, then the end is already inscribed in its properties. the mirror written not in galaxies, but in quantum numbers. Meanwhile, underground detectors like Xenant, Luxeplin, and Pandex search for dark matter particles. Though dark matter is not the direct cause of cosmic acceleration, its properties intertwine with fate. If dark matter proves to be exotic, decaying, self-interacting, unstable, then the mirror shifts. The scaffolding of galaxies may erode, altering cosmic structure and hastening entropy's triumph. If dark matter is eternal, then the cosmos drifts more gently into silence. Each particle caught, each trace detected, adjusts the reflection. Supercomputers add yet another layer. Simulations of cosmic evolution run on machines spanning continents. Attempt to evolve the universe forward from known conditions. They test models of heat death, rip, and bounce. In these simulations, galaxies dissolve, black holes evaporate, dark energy dominates. Some runs end in silence, others in rupture, others in cycles of fire and rebirth. These are not guesses but rehearsals. The universe's possibilities played out in silicon. Each iteration a fragment of the mirror, yet the most daring tools are not physical, but conceptual, frameworks of quantum gravity that seek to unify relativity and quantum mechanics. Loop quantum cosmology suggests that singularities may be avoided, that the universe bounces rather than collapses. String theory envisions higher dimensions, in which our cosmos is one brain among many. Both attempt to peer beyond the mirror itself, to understand whether endings are boundaries or transitions. Though untested, these frameworks guide experiments, pointing to signatures in the CMB, in gravitational waves, in particle physics, that could reveal whether our universe is terminal or cyclical. Together, these tools form a symphony of observation. Telescopes gaze outward, detectors listen inward, colliders probe beneath, simulations extend forward. From mountaintops, from deep mines, from orbit, humanity stretches every sense to grasp the reflection of destiny hidden in beginnings. And yet, even with this arsenal, certainty remains elusive. The mirror is not clear glass, but fractured crystal. Some reflections suggest silence, others fire, others rebirth. Each experiment sharpens one edge, while leaving another obscure. Perhaps this is the final lesson of the tools themselves. The universe may reveal its destiny not in one instrument, but in the harmony of many. Still, the pursuit continues. For to look into the mirror of the end is not only to predict fate, it is to understand origin. Each experiment draws the circle tighter, showing that beginnings and endings are not two but one. Folded into the same fabric, the cosmos has already written its reflection. Humanity builds its instruments not to change it, but to finally see it, to polish the mirror until its surface reveals what has always been there, the end, waiting patiently inside the beginning. The search for the universe's destiny is not only a scientific pursuit, it is a question of meaning, of fragility, of existence itself. For in studying the cosmos, humanity does not merely peer into stars and galaxies, it peers into a mirror. And in that mirror, reflected faintly, is not just the end of the universe, but the end of everything we know, including ourselves. The imagery returns, the mirror that shows the end first, a glass not of silver, but of space-time, not of reflection, but of inevitability. From the very first second, when the universe blazed in fire and expansion, the laws of physics etched into its structure the trajectory of time. Entropy began its climb. Expansion began its march. Dark energy began its whisper. And in that whisper lay the story of endings, endings we are only now beginning to hear. The cosmos as mirror reflects more than physical processes. It reflects the paradox of being, for every birth contains its death, every flame its ashes, every heartbeat its final silence. Stars ignite only to exhaust, galaxies form only to drift apart. Even black holes, once thought eternal, now appear to fade through Hawking radiation, leaving behind nothing but faint whispers of heat. Existence itself is sculpted by disappearance. To live in such a universe is to live knowingly in impermanence. Yet this impermanence is not absence of meaning, it is the very source of it. If the universe marched endlessly in perfect equilibrium, without change, there would be no story, no life, no consciousness. Entropy may write the end, but in doing so, it permits the middle. It is the tilt of time that gives rise to memory, to growth, to the fragile architecture of thought. The mirror of fate, therefore, reveals not despair, but perspective. Humanity's lives, so brief compared to stars, are not outside this reflection, but within it. Our own beginnings carry our endings, our own time arcs toward silence. Yet within that arc lies beauty, the knowledge that to exist is to be part of the unfolding reflection of the cosmos. We are temporary, yes, but we are also the cosmos looking into its own mirror. Still, unease lingers. If the end is inscribed in the beginning, then what of freedom? If entropy dictates silence, if expansion dictates scattering, if vacuum instability dictates collapse, then are we simply passengers on a predestined voyage? Does the mirror not only show the end of stars, but the illusion of choice itself? Here, philosophy stretches into physics. Some cosmologists suggest that the arrow of time, while universal in trend, allows local eddies of order, islands of complexity in a sea of disorder. Life may be one such island, arising not against entropy, but because of it. The mirror shows the end, but within that end lies space for creation. A musical score may be finished, its final note determined, yet, within the measures between, melodies still soar. Humanity's choices, are those melodies fleeting? Yes, but genuine. Others push further. What if the mirror reflects not one ending, but many? If the universe is part of a multiverse, then our end may be another's beginning. If conformal, cyclic cosmology holds, then the ashes of our heat death may seed a new eon. In these frameworks, the end first revealed is not a terminus, but a transformation. The mirror reflects endings, but endings that blossom into continuity. And yet, even if rebirth exists, the lesson remains. All that is visible now will pass. The stars that guided ancient sailors, the galaxies mapped by Hubble and Webb, even the atoms of our bodies, all will dissolve. The mirror's reflection is inexorable. The question becomes not whether we can escape it, but how we face it. To some, this inevitability is crushing. To others, it is liberating. For if everything dissolves, then value cannot be found in permanence. It must be found in the moment, in the transient beauty of starlight, in the fragile warmth of consciousness, in the brief span when matter organizes itself into awareness. The universe is a story told against the silence of its own end. 2. Listen to that story is to live fully. This reflection leads to a profound symmetry. The universe and humanity mirror one another. The cosmos began in fire, will end in silence. We are born in light, will end in death. The universe contains entropy, we contain mortality. To understand the universe's fate is to understand our own. The grief and wonder of physics is that it does not separate us from the cosmos. It places us within its destiny. Consider the mirror in practical terms. Every observation we make of distant galaxies is already an observation of the past. We never see the present as it is. We see the light delayed. In this sense, we always look into a mirror that reflects not what is, but what was. If the future is already written in the beginning, then the present itself is a reflection, a shimmer caught between two inevitabilities. Science, therefore, becomes more than calculation. It becomes an act of contemplation. Telescopes, colliders, detectors, these are instruments not just of data, but of meaning. They sharpen the mirror so that we may see more clearly the destiny inscribed in origins. The act of science is humanity's way of facing the mirror without flinching, of looking at the end and saying, even so we will understand. And yet, the mirror does not remove mystery. It deepens it. For even as we trace expansion, entropy, dark energy, vacuum decay, new questions bloom. Why does anything exist at all? Why do the laws of physics take the form they do? Why should beginnings contain endings, and endings beginnings? The mirror reflects not only what science can measure, but what philosophy cannot answer. Perhaps this is its final lesson, that the end is not only scientific, but existential. To know that all things dissolve is to be invited to live differently. Not in despair, but in reverence. Not in clinging, but in wonder. To look into the cosmic mirror is to see our fragility, but also our connection, that in our brief lives we participate in the greatest symmetry of all. The universe knowing itself through reflection, the closing imagery forms, the cosmos, vast and cold, stretching toward silence. Galaxies fading like embers, stars vanishing like sparks, black holes evaporating, their heat whispers dissolving into background noise. At last, the universe reaches stillness. The mirror darkens, yet its reflection remains. The end was always contained in the beginning, just as silence is always contained in music. And in that silence, one truth endures. To exist at all, to glimpse the mirror even briefly, is an immeasurable gift. The final question rises, quiet, haunting. If the universe carries its destiny in its first light, then what does it mean that we fragile beings of dust and fire are able to see it, to know the end before it comes, to look into the mirror of time and find not only the fate of stars, but the reflection of ourselves?